Hi everyone, I'm Thilak from Nutanix. I'm here to talk about this topic about affinitizing guest packet flows. Now here's the problem statement. Now you have a high density NICs where one single RxQ will not be sufficient to drain all the packets that comes out of the NIC. So you need multiple RxQs. And this is on a multi-NUMA system, and the VMs as such have a single word queue pair. So what happens is with RSS, the packets, the flows belonging to VM1 can land onto any of these RxQs. For example, a flow could land onto RxQ1 and another flow belonging to the same VM could land onto RxQ2. Now, as a result of this, you will have to, when the PMD thread tries to put this on the VM1, both will have to hold a spin lock. And the other problem is that the packet that lands onto an RxQ, which is being handled on a NUMA, which is far from the VM's NUMA memory, is going to suffer an memory access across NUMA. So how do we solve this? So the NIC itself has some of the flow steering capabilities, and these are exposed through DPDK with RT flow APIs. And so when a VM comes up, you know the VM's NUMA memory as well as the VM's MAC address as well. So with this, you could actually steer the flow with a match condition in action. So the match condition could be as simple as, hey, match this destination MAC address, and the action could be something as good as like steer towards this particular RxQ. And with this, all the packets destined to the VM always land onto the same RxQ. So if they land onto the same RxQ, then you wouldn't have the spin lock, which you would see if the packets land onto different PMD threads. And by steering these flows towards the RxQ, which is handled by the PMD thread, and if they are on the same NUMA as the VM's NUMA, then the cross-NUMA memory access is also kind of handled. So the typical workflow for this is a VM comes up, you have the guest MAC address, and with the guest MAC address, by using OVS DPDK set interface, you could actually program a flow saying that land onto this RxQ based upon destination MAC address. And with this, this is the test result that we have. So this is a PVP test where you have a package-gen DPDK running on a host, and you have two VMs running on top of OVS DPDK using virtual user interfaces. And inside the VMs, you have a test PMD which turns back the packets around. So with that, the results are what you see in the bar graph. The blue one is the one in the master, and the orange one is the one with the RxQ steer. The gray one was a result of another thought process that I had after looking at the code. So I realized that the mempool for these RxQs are determined by the NUMA ID to which the NIC is attached to. Now, if you kind of make changes so that we could actually provide an mempool based upon the PMD's NUMA, then we would have better gains to have better gains. So with this, in the tabular column, you could see that with the master, there was this spin lock that you could see on the perf. And with the PCM NUMA tool, you could see that there was remote DRAM access as well. With the RxQ steer, you could see that the spin lock is no longer seen on the perf top, and you still see the remote DRAM access. And with the RxQ steer plus the local mempool, you could see that the remote DRAM access is also going away with the PCM NUMA. With this, the possible applications are, yes, since it optimizes the packet path and memory access, it gives us better performance. And the other application for this is that you could actually isolate certain workloads alone. In this case, like you could isolate certain packets towards a guest alone on a single PMD thread so that it doesn't get any kind of interference from the other guests. This in essence is like in Linux kernel, you have the flow director, which is the ntuple. So a similar kind of interface could be built on top of this. Either it could be a part of the DPDK or OVS DPDK's VS-Cuttle interface, or it should be a separate secondary process for OVS DPDK as such. And pretty much I've submitted a patch for this. Please take a look and give me some comments and suggestions. And that's pretty much I have for this talk.
All right, round of applause for Thilak. Thank you so much. Thank you so much for contributing for your patch. We'll appreciate it. Now we're gonna open up for questions. See if anybody in the room has any questions. Anyone? Going once? I guess we're gonna wait a little bit for any virtual questions. If not, then we can, start. Oh, we have one question in the back.
Thank you, cool stuff. Just wondering, are you using the RT flow interface itself?
Yeah, RT flow, yes.
Or is that like useful enough for you? Because when I tried using this, that was not like, you didn't capture all the Nico is doing, and it was not like very portable.
Yeah. Yeah, so it has its challenges in terms of portability across NICs, but you will have to claim that these things work on these NICs and it doesn't work on these NICs. Yeah.
Yeah, so it's actually nice if you can actually use the interface they provide. It's probably more portable.
Right.
Yeah.
Right. Yeah. So the other thought process that I had is like in kernel you have the each tool flow tuple, the flow director, right? Like you could build up a secondary application for OVS DPDK, and that way it could be portable or could take into those handles those scenarios as well.
Thank you. Cool.
All right. Any more questions in the room? No more questions? Any questions online? All right. I guess we can move on to the next talk.